This is lesson 4 of our topic geometric sequence, and this is all about the nth term of a geometric sequence and how to solve it. And at the end of this video, you will able to determine the nth term of a geometric sequence. To easily find the nth term of the geometric sequence, we will use the general rule. A sub n is equal to a sub 1 times the common ratio to the power of n minus 1. So in solving, just write the general rule of the sequence and simply substitute the variables with the given values. For example number 1, consider this sequence: negative 6, negative 24, negative 96. Find the 10th term of this sequence. Before we solve the 10th term, we need to find the common ratio first. Remember on how to find the common ratio? We need to divide any term to the term before it. So let's have negative 24 divided by negative 6. Our answer is 4. Now that we have the first term and the common ratio, let's replace those values into the formula. A sub n will be a sub 10. Because we are looking for the first term, a sub 1 is negative 6. R is negative 4 and n is 10. Let's start solving the exponent 10 minus 1. That is 9. Then let's solve 4 to the power of 9, which is 262,144. Again, 4 to the power of 9 is we multiply 4 9 times, not 4 times 9. Then we multiply the answer of 4 to the power of 9 to 6. So we get 1,572,864. And this is the value of our 10th term. For example number 2, find the 6th term of the sequence 160, 80, and 40. Again, let's start by solving the common ratio, 80 divided by 160. Let's rationalize the denominator, 80 over 160. And both values are divisible by 80, so 80 divided by 80 is 1, and 160 divided by 80 is 2. So our R, or our common ratio, is 1/2. Now let's substitute these values to our formula a sub n, where a sub n is a sub 6, a sub 1 is 160, R is 1/2, and n is equal to 6. Now 6 minus 1 is 5, then 1/2 to the power of 5. We get 1 over 32. Then we multiply it to 160, so we get 160 over 32. Now both values are divisible by 32, so 160 divided by 32 is 5, and 32 divided by 32 is 1. Therefore, our 6th term is equal to 5. For example number 3, let's find the 15th term of this sequence. Again, we start by solving the R. So 3z to the power of 7 divided by 3z to the power of 3. Let's rationalize first the denominator. It will become 3z to the power of 7 over 3z to the power of 3. Now 3z divided by 3z is equal to z. And our exponent, since we are dividing the terms, we are going to subtract 7 with 3. So our R is equal to z to the power of 4. So let's substitute these values to our formula. A sub n is a sub 15. A sub 1 is 3z to the power of 3. R is z to the power of 4, and n is 15. Now, let's start with the exponent, 15 minus 1. That will be 14. Then we multiply z to the power of 4 to the power of 14. We get z to the power of 56. So what we did here is we just multiply 4 with 14. It is just the same result if we add all the 14 exponent of 4 together. Then we multiply 3z to the power of 3 with z to the power of 56. So our 15th term is 3z to the power of 59. For the fourth example, let's find the 7th term of this sequence. Again, solve for the r first. So r is equal to 12 times the square root of 2 divided by 2 times the square root of 6. Let's rationalize the denominator. 12 square root of 2 over 2 square root of 6. Then multiply both values to its denominator. So 12 square root of 2 times 2 square root of 6 is 24 square root of 12. And 2 square root of 6 times 2 square root of 6 is equal to 4 times the square root of 36. Since 36 is a perfect square, we will change it into 24 times the square root of 12 over 4 times 6. Then we multiply 4 times 6, that will be 24 times the square root of 12 over 24. Then since 24 and 24 is divisible by itself, so it will be 1. And what remains is the square root of 12. We factor the square root of 12, it will be square root of 4 times square root of 3. Since square root of 4 is a perfect square, our final answer will be 2 times the square root of 3. Now let's substitute our given values to our formula. A sub n is a sub 7, a sub 1 is square root of 2, our r is 2 times the square root of 3, and n is 7. Let's solve first the exponent. 7 minus 1 is 6. Then we solve 2 to the square root of 3 to the power of 6, and that is 1728. And since we cannot multiply 1728 with the square root of 2, our final is 1728 times the square root of 2. And this is our 7th term. For our 5th example, this time we are going to look for the first term of the sequence, given the 5th term and the common ratio. To solve for the first term, let's replace n with the position of the given term. A sub n is equal to a sub 5 and n is equal to 5. Then let's substitute these given values to our formula. A sub n is a sub 5, r is 5, and n is 5 also. Now, since we know the value of a sub 5, we will use its value, 2,500. And 5 minus 1 is 4. Then let's solve 5 to the power of 4, which is 625. Then let's transpose 625 by dividing itself to both sides of the equation. 625 divided by 625 is 1, and 2,500 divided by 625 is 4. Thus, our first term has the value of 4. That's it. I hope this video will help you. Don't forget to hit the like button and subscribe for more videos. Thank you and see you in our next lesson.